So this is 8-4, part 2, and we just have this one last example to finish up here. And I went ahead and typed that note here that we wrote on the previous example, same thing that I wrote before. And now we're going to try the same strategy with a 3 by 3 matrix. So we have 1, 0, -2, -1, -2, -3, 1, 1, and 0. I'm going to put that line there, and then we've got the identity matrix. And I'm going to start combining some steps here. So I'm going to multiply 2 times row 1 and add it to row 3 to get that 0 right here. So let's see, we have 2 row 1 plus row 3. And this is another opportunity just to practice those row operations. And so 2 times 1 is 2 plus -2 is 0. 2, and then it's going to be -5. And then 2 times 1, and that'll become a 2. And then this will become a 2, and 0, and 1. And from here, I'm going to do 2 steps in one. Actually, maybe I won't. I'm just going to multiply it by -2. I'm sorry, -2 to row 3. So unfortunately, I don't have nice numbers here to cancel these ones out. I already have my zeros here, and I don't want to mess those up. So what I'm going to do is I'm going to multiply row 3 by 2, and that's going to allow me to use row 2 to cancel it out. So for now, I'm just going to multiply by -2 to row 3. So I'm not canceling anything out. I have 1, 0, 0, -1, 1. Those didn't change. -2, 1, 1, 0, 0, and 0, 1, 0. And the only one changing is row 3, and I'm multiplying by -2. So that's going to become 10, -4, -4, and 0, -2. And now I can use row 2 to cancel out. So I'm going to multiply 5 times row 2 plus row 3. Row 1 is not changing. Neither is row 2. So I multiplied by 5, 5 here and added, and 5 here and added, 5 here doesn't change, 5 here and added, and doesn't change. And so that's what we should have. This row looks how we want, and these rows are not too far off. So now I'm going to start combining some steps. I'm going to actually multiply, maybe I'll zoom out here a little bit, there we go. I'm going to multiply row 3 by -1, and I'm going to add it to row 2, and I'm going to add it to row 3. So -1 times row 3 plus row 1, and -1 times row 3 plus row 2. So row 3 is not changing. In fact, it's not going to change anymore at all. And then multiplying that -1 and adding is just going to give me a 0. And that's going to be -2 still. That'll become a 0, -1, and that'll cancel. -1, that'll make that a 4. -1 will give me -4 here. And -1 and adding will give me a 2 here. And then doing the same thing to row 1, this is not going to change, and this is not going to change. And -1, that's going to become a 0. -1, that's going to become a 5, -5, and 2. Okay. Now you'll notice that I did not make this a 1 yet. It's a higher priority to get these as a 0, and then I can try and work these out nicely. So I'm going to multiply -1/2 times row 2, and then I'll use that for row 1. So moving this up a little bit, I'm multiplying -1/2 times row 2, 1, 0, 0, negative 1. I'll just go ahead and copy these rows because they're not changing. And this row is the only one that's changing. This becomes a 1, 0, negative 2 to negative 1. And now I can use row 2 to cancel out that 1 in row 1. So row 2 plus row 1. So I'm almost there. I'm going to copy down rows 2 and 3 real quick. And then adding this will give me a 0 here. That doesn't change. And I'm going to end up having 3, negative 3, and 1. And what this means, this is A inverse. So A inverse is equal to 3, negative 2, negative 4, negative 3, 2, 5, 1, negative 1, negative 2. So this right here is the inverse of matrix A. And that is the end of section 8-4.